Today we'll look at using determinants and Cramer's rule. First we're going to look at why Cramer's rule works, and then we're going to find solutions of systems of two linear equations with two variables using Cramer's rule. So the question starts, what is Cramer's rule? Cramer's rule is a way to solve systems of linear equations that look like this, but we're going to use determinants. The reason we can use determinants is because if we solve this system by either substitution or the linear combination elimination method, we end up getting two values for x and y. X equals, in this case, dE minus BF over AD minus BC, and y equals AF minus CE over AD minus BC. Now if you look at the numerators and denominators here, they look a lot like discriminants, and determinants, and that's because they are. If we create a matrix of just the coefficients of the variables, we would get something that we call determinant D, and it ends up being A, B, C, D. If we take that determinant, we get AD minus BC. So there's the denominator of both our equations. The numerator of both our equations, or numerator of each equation, well, the numerator of the x equation, the x, we'll call d of x. And what we do is, instead of writing the coefficients of the x terms, we put e and f in its place. So it's EF and then BD. Multiply that out, we get this numerator up here. To get this numerator here, we're going to call that dy. And dy equals, this time we keep the x coefficients, but we change the y coefficients to e over f. And they'd be our three determinants. So x becomes dx over d, and y becomes dy over d. So all we have to do is calculate these three determinants, and we can figure out the values of x and y by dividing the numbers we need to divide. Let's put this into practice. If we put this into practice here, we're going to have three determinants. We're going to have d, dx, and dy. D is just the coefficients, so 2, 3, -1, and 5. Calculating that, we get 2 times 5, which is 10, minus 3 times -1, -3, that gives us 13. dx is, we substitute out the x coefficients for the constants, so it's 6 and 22 instead of 2 and 3, but the -1 and the 5 remain. Multiply this out, you get 30 minus -22, or 52. And for dy, this time it's 2 and 3, but we switch out the -1 and 5 for 6 and 22. And multiplying this out, we get 44 minus 18, which gives us 26. To get x, we take dx, or d sub x, and divide it by d, which is 52 divided by 13, which equals 4. To get y, we take dy over d, which is 26 over 13, which is 2. So my solution to this system of equations is the point 4, 2. And there's your answer. Let's try this again. Same setup, same everything, we just find the determinants, and we can then do the division. So when we do that, we get D is 2, 3, 4, 7. 2 times 7 is 14. 4 times 3 is 12. So that value is 2. D sub x. This time I'm switching out the 2 and the 4 for 3 and 1. So it's 3, 1, 3, 7. 3 times 7 is 21. 3 times 1 is 3. 21 minus 3 is 18. D sub y is 2, 4, 3, 1. And 2 times 1 is 2. 4 times 3 is 12. So it's 2 minus 12, that's negative 10. So x is 18 over 2, or 9. And y is negative 10 over 2, which is negative 5. So your solution is 9, negative 5. And that's all it is. Now, as with systems of linear equations always are, you're going to eventually get to the position where you're going to have either parallel lines or two equations that represent the same line. And so you'll have either no solution or an infinite number of solutions. So let's look what happens when we use Cramer's rule, and how can we tell. So here we've got this equation, 2 minus xy equals negative 1, and the 2x minus y equals 4. So first we find the determinants. So we get 2, 2, negative 1, negative 1. So that equals negative 2 minus negative 2. That equals 0. Now this is going to be an issue, because to find x and y we divide by this number, and since this is 0, weird things are going to start happening. So what we do is we check dx and dy. If they are 0, then it's the same line and I don't have to worry about it, there's an infinite number of solutions. If dx or d sub x and d sub y are not 0, then these two lines are parallel. So really we could just check one. But we check both just to make sure, because one could be 0, one won't be 0, and it gets a little strange. So we just check both. Negative 1, 4, negative 1, negative 1. Negative 1 times negative 1 is 1. 4 times negative 1 is negative 4, so we're subtracting negative 4. So we get 5 for dx. And for dy, we get 2, 2, negative 1, and 4. 2 times 4 is 8. 2 times negative 1 is negative 1, so we get 9. Oh, sorry, negative 2, so we get 10. But either way, it's still not 0. Since d is 0 and dx and dy aren't 0, these lines are parallel. Lines are parallel, so there is no solution. So let's look at what happens in the other instance. 3x plus 2y equals 2, 6x plus 4y equals 4. Let's work this through. The determinant, 3, 6, 2, 4. 3 times 4 is 12, minus 6 times 2, which is 12, which gives us 0. So it's either going to be parallel or the same line. Check dx or dy. So you get 2, 4, 2, 4, or 3, 6, 2, 4. Well, we know 3, 6, 2, 4. We've just done the calculation up above. That's 0. If we do check 2, 4, 2, 4, 2 times 4 is 8, minus 2 times 4, which is 8. That's also 0. They're all 0 in this case. Since they're all 0, these are the same line. These are the same. And there are an infinite number of solutions. And that's what's going to happen. They're all the different possibilities. So all you're doing is multiplying and adding and subtracting, and that gets you solutions.